Hey everyone, it's that math magician, and on this video we're going to look at our final two laws of exponents. Let's go ahead and start off with our fourth one, and we're going to start with an example to kind of develop what that fourth law of exponents are. Now, we're going to have to use some of the law of exponents that we've already discovered in the previous video to help us develop this fourth law. So let's go ahead and let's look at the expression x to the 8th power over x to the 8th power. Well, thinking about this in terms of our law of exponents, we learned that if we have a division problem with variables, that all we have to do is take those exponents, the 8 and the 8, and we subtract them. So x to the 8th minus 8 power, that will just reduce and simplify to x to the 0 power. But our question here is what does it mean for an exponent to be to the 0 power? What does that mean? And that's what we want to figure out. So instead of just using this law of exponent to subtract the exponents, instead, I think it might be beneficial if we actually look at the expanded form and what it reduces to. So I'm going to go ahead and write out my 8x's over the other 8x's and we're going to, now that we've expanded it, we're going to start to simplify it. And hopefully we can see that all of these are going to turn into ones because they are all reducing to ones. And so every x gets canceled out. And so we're just left with 1 over 1. And 1 over 1 just reduces to 1. So I want you to think about that. Okay, think about that for a second. When we did it the new way with our law of exponents, we said that we just had to take the 8 minus the 8 and that it became x to the 0. What we are showing here is that x to the 0 equals 1. Okay, anything to the 0 power is going to be 1 because what happens is all of those variables are canceling out. And when they are canceling out, you're just left with 1 over 1, which is 1. So that is our fourth law of exponents. Anything to the 0 power just becomes 1. And let's go ahead and generalize that so we have that. We're going to say that x over m divided by x to the m, well, that just becomes x to the m minus m, which becomes x to the 0, and anything to the 0 power is 1. Great. All right, let's use the same idea now for our fifth and final law of exponent. So for this one here, we're going to look at another similar problem like this, but I'm going to change it up a bit. I'm instead going to write this out as x to the 7th over x to the 8th. Now again, I want to use that law of exponents from the previous thing, what we did right here. Following this guidelines, I would just take this and I would do 7 minus 8. Well, 7 minus 8 is -1. So I'm stuck with this term, this exponent that's negative, and now I have x to the -1. I want to figure out what does it mean to have a negative exponent. So let's look at this as we expand it out. I'm going to have 7 x's up here. I'm going to have my 8 x's on the bottom. And let's go ahead and start canceling them out just like we did before and see what our result ends up being. So all of these x's here become 1s because they are canceling each other out. And look what we are left with. We're left with a 1 on the top and we're left with an x on the bottom. So we now know that x to the negative 1 is really just the same thing as 1 over x. Okay, let's do one more example here. Let's think about this again. What if I'm going to scroll up here. What if I look at x to the 7th power over x to the 9th power? Well, if I'm looking at that, then again, I want to think about our law of exponent. I'm just supposed to take the 7 minus the 9. Well, 7 minus 9, that makes negative 2. So again, let's expand it out and see what's happening. I'm going to have 7 x's on the top. I'm going to have 9 x's on the bottom. And again, what I want to do is I want to start canceling out all of the pairs of x's. So I start creating all these 1's here. And look what we have. We have a 1 on the top. We have x times x. And that just simplifies to x squared. And our answer here ends up becoming 1 over x squared. Are we seeing that if we have a negative exponent, what that actually equals is it actually takes that base, it puts it in the denominator over 1, and then the exponent then changes to be a positive, right? There is no 1 on here, but we know that if there is no exponent, it is a 1. That's that's what's occurring there. So let's go ahead and generalize this out so we can see it. If we have x to the negative m power, all you have to do is you put that x underneath a 1, but that x will still have the exponent of m, but it'll be positive. All right, everyone, that was the final 2 laws of exponents, and I'll see you on the next video.